Hey everybody, this is the Robert Kablinski section on why we should reconsider worksheets. I almost want to read a little bit of the blip, why we should reconsider using worksheets and what we should be doing instead. Robert Kablinski says, if you didn't like doing worksheets as a child and want a better option to use as a teacher, then come and learn about an alternative that kids love doing. Helps build conceptual understanding, leads to great conversations, and reveals hidden misconceptions. So let me present my screen. And we will get to Robert Kablinski, one of my favorite mathematicians.
Okay, so if you have followed me for any amount of time, then you probably know I'm not a fan of worksheets, which is why I am so excited for this next session by Robert Kablinski, because he sums up in just the first few minutes my feelings about worksheets. And if you were like me, I never really quite had the right words to explain it to colleagues and even to parents of students. So that's what he's going to start us off with, is giving us the understanding and words to use about why worksheets really don't help our students. Now, he doesn't spend too much time on that because the rest of the time he is going to be sharing with us ways that we can be building students' procedural and conceptual understanding in ways that are not reliant upon worksheets. And I hope you enjoy his session on how to implement these types of math tasks in your classroom so that we aren't constantly going to worksheets. Worksheets have been easy because they are quick and easy to use, so easy to find, but Robert's going to tell us some other alternatives that are also quick and easy to implement and yet way more powerful for our students. All right, here's Robert.
Hi everyone, my name is Robert Kablinski and I'm so excited you made time to watch my webinar. Now, before we begin, I want to actually share with you a link so you can download a handout for this webinar. So if you look at the bottom of the screen, it says robertkablinski.com/VMS20. If you head over there right now, you can download a handout for the webinar, as well as some other resources I'll be sharing. So my workshop is called, this webinar is called Why We Should Reconsider Using Worksheets and What We Should Be Doing Instead. My goal for the presentation is to give you actionable ideas you can use in your classroom when you return. Now, some of you already agree that worksheets may not be ideal, and I'm sure I'll share ideas that you've been advocating for years. Others may come in with more skepticism, and maybe you're wondering, like, if I'm actually going to share anything that's going to make a difference for you and your students. I believe that what I'll share in this presentation is the single biggest bang for buck change that we can make in math education, and I cannot wait to tell you more about it. So let's talk about the plan for the webinar. We're going to begin with who am I briefly. We'll talk about what's wrong with worksheets, what we should be doing instead, how do we do it in our classrooms, where we can get more of these kinds of problems, and finally, what comes next. So my name is Robert Kablinski. I've trained lots of educators around the world. I've been a teacher. I work for Downey Unified School District as both a teacher and teacher specialist, an instructor for UCLA, and presenter at conferences around the world. I've also trained many educators for these organizations and many others. So let's talk about what's wrong with worksheets then. First, I want to define what I mean when I say a worksheet, because I think that the term worksheet can mean different things to different people. So when I say worksheet, I mean things like this, right? Sheets that have essentially the same kind of problem over and over again. I think I also mean pages like these that have like riddles at the bottom, right? So you fill in these, you answer these questions and you get letters, and then you kind of answer these, cutesy questions at the bottom. Now, I'm sure that someone has taken a really interesting and thoughtful investigation, put it onto paper, and called it a worksheet. But for the purposes of this webinar, I'm not considering those to be what I'm labeling as a worksheet. So with this sharing a common definition of a worksheet, let's talk about the best case scenario. In the best case scenario, kids get just the right amount of practice and better understand a procedure. But perhaps kids who prefer to work by themselves, maybe they also get to think independently. How often does this best case scenario happen? I'm not sure, so let me share my concerns about worksheets. Sometimes it seems like after doing 4 or 5 problems, Kids either understand what they're doing or they feel like they're just repeating the same mistakes over and over again. That leaves 20 plus remaining problems on the worksheet feeling like busy work. And aside from those building those procedural skills, there are rarely opportunities to develop real sense making. Worksheets rarely lead to great conversations, and when they're done with a partner or small group, it often becomes a game of divide and conquer, right? Where each person is doing a part of the worksheet rather than talking about what they learned. Also, worksheets don't really give us a lot of information about what kids know. Like, we definitely see when a kid gets a problem wrong, and we've all had that, but we also had kids who get problems right, and later we find out that they still don't really understand the concept. So a kid who gets all the problems on the worksheet right isn't necessarily mastering the concept. So what I wonder is why we keep using them. Like, do we use them because they're the best way to teach? Or is it because many of the resources we're given are filled with them? Maybe it's because that's the way it seems like it's always been done. What I wonder is, what if there was a way to keep the best parts of worksheets, including the practice and time for students to think on their own, but make the work feel fun and meaningful, help students make sense of mathematics, give us great classroom conversations, and give us richer formative information about what kids know so we can modify our instruction while we still have time. There is a way to do this, and that's what I'd like to share with you in this webinar. So that's what's wrong with worksheets. Now let's talk now about what we should be doing instead. I want to give you 3 problems to consider that are all on subtracting 3-digit numbers. So when we were looking at the worksheets, like I said, they were all on subtracting 3-digit numbers. And I want you to now take another approach at a series of 3 problems that are slightly different. So if you haven't had a chance yet from the handout, please take 30 seconds and solve this problem. You might think, oh, this is too easy, I can just do it in my head. But I want you really to think about how you would solve it, maybe how your students would solve it. You'll see these blue zigzags at the bottom. They'll slowly shift from blue and really from blue to green. And when they're green, we'll come back together. So this is a fairly typical problem for subtracting 3-digit numbers. If a student gets this problem wrong, we know that's not good, right? We know we need to do some intervention. But if she gets it right, does it guarantee that she deeply understands this concept, right? Like, we've all had those students who appear to understand the concept and only later found out that there were hidden misconceptions. So, like, this problem by itself isn't a sure way to measure understanding. So now let's look at a slightly different problem. So it says, using the digits 1 to 9 at most 1 time each, fill in the boxes to make 2 sets of 3-digit numbers that form a true number sentence. You may reuse the digits for each set. So let me explain what I mean here. You'll see this 3 boxes right here. That means you place 3 numbers there and you make a 3-digit number. Like if you put 1, 2, 3, you'll have 123. Then you'll put another 3-digit number there. So you use 6 of the 9 digits. You can only use each number once. So you cannot put, like, say, 111 minus 291 or something like that. You also cannot use a 0. So I'm going to now give you 2 minutes to work on this. It's not easy. So if you're struggling with it, join the club. After the 2 minutes, we'll talk about kind of how I approached it and the struggles I had. But again, you're looking for these blue zigzags to turn green, and that's the sign we're going to come back together. All right, let's talk about this problem. Now, you may not have had a chance to finish the problem, but hopefully you got it in a couple of attempts. This problem is not easy. Here's how I approached it. When I first started, I thought, okay, let me try 987 and then see what that gives me. So 987 minus 291, and you can repeat. So just to be clear, you can use a 2 to the 9 to the 1. It doesn't count as numbers you've used. So 987 minus 291, that gave me 696. And that I cannot do because I've repeated a 6. I've also repeated a 9. So that is not acceptable. All right, number 2. I tried 853 thinking I'll spread out the digits a little bit more. But unfortunately, that gave me 562, and I had already used the 5, so that does not work either. I tried again, 843, because the 5 was the problem last time, and I got 552, so not so much there. 832, and finally I got 541. And the perspective I kind of want you to have here is that, like, it took me, the guy who made the problem, 4 attempts just to find one of 2 number sentences for a 3rd grade problem. So, I mean, I just want you to realize, like, it's not easy. Like, you can simultaneously know how to subtract, but you kind of have to, I don't want to say guess and check, but you've got to, like, really start thinking, like, how does choosing the digits affect what the sum is going to be, right? Or the difference in this case, right? Like, if you were to pick 123 minus 291, that's going to be a problem for the way this problem is set up, since there are not negative numbers. So just, having some sort of conceptual understanding is important. So I hope you're already beginning to see the potential from a problem like this. Like, I bet you can imagine students who would rock problem 1, but would struggle with problem 2. I want you to think about what that means, right? Like, if they should be able to, if they have deep conceptual understanding of subtracting 3-digit numbers, should they be able to solve problem 2? What does that mean if they can't? So let's move on to problem 3 now. Problem 3 has a lot of similarity to problem 2, but let me explain the differences. So using the digits 1 to 9 and most 1 time each, fill in the boxes to make a difference that is as close to 329 as possible. So again, you can use 1 to 9, but you cannot use 0. You cannot repeat a digit, and you can only put 1 digit in the box. So I want you to essentially make 2 different 3-digit numbers and subtract them, and you want that difference to be as close to 329 as possible. And it's not the Price is Right, so it's not, so you can have a little bit above 329, like 330 and 328 are equally good, 329 being the best. So I'm now going to give you 3 minutes to try this problem. Again, you may not have enough time to finish it, but hopefully you'll have some time to try a few times. So let's come back together. Again, this problem is not easy. Like even if you have a calculator, it's likely going to take you multiple attempts. I mean, if students are just randomly picking numbers and subtracting them, it's going to take a really long time to figure out the answer. Ultimately, what you start to realize is that this problem can force students to move beyond being a human calculator and help them find a need to build and use conceptual understanding. For example, I hope students will realize that the number on the left has to be greater than 329, or the difference will be closer to 0 than 329. Like, but you still have to know more than that, right? Like, let's say we start with 987. Like, now what? Like, do you just start randomly guessing the number on the right? Or do you start thinking, like, I guess the number on the right needs to be about 300 or even 330 less than the number on the right. The number on the right has to be, 300 or 330 less than the number on the left. So you might say like, I don't know what this is, or maybe you'll say, okay, maybe this should be like a 6, right? Even using that level of conceptual understanding will really help. Kids might approach it differently, we might approach it differently. Like I'm sure a lot of us even thought about it like, what 3-digit number plus 329 equals my other 3-digit number, right? So if we prefer addition and we understand the relationship between addition and subtraction, then we have this flexibility to use the tool that best meets our strengths. So problems like problem 3 can replace entire worksheets because this single problem has the same kind of repetitive practice like you'll find in a worksheet built into it. We call problems like problem 2 and 3 open middle problems. And I hope you're getting excited about their potential. So I was curious about like how would third graders approach a problem like this? Like how would they do with this, right? So I asked teachers on social media to try this problem with their third graders and kind of send me back their data. And so here's the data that we found. I want you to take a second and estimate how many students, or really what percentage of students, correctly solve problems 1, 2, and 3. So here's what the data showed. Let's look at problem 1. 62% of students correctly solve problem 1. Now, maybe that's a surprise, maybe it's not a surprise, but the most important part of the graph is not up yet, right? Here's problem 2, 39%. And what I really want to focus on, though, is the difference, right? What does this red bar mean? Because this red bar right here might be the single most important part of this entire presentation. If you believe that students who deeply understand how to subtract 3-digit numbers should be able to do problem 1 and problem 2, then this 23% represents a false positive. They're the kids who appear to know what they're doing when we just give them problem 1, but in reality have misconceptions that are hidden because we're using problems that don't show that, right? When we use superficial questions, we get superficial information back about what children know. So, and you see this even more pronounced with problem 3. So I really think that this is something that we have to figure out and use more of if we want to spot these hidden misconceptions. So if you've enjoyed comparing these 3 problems but want to see examples at your grade level, I've included examples from kindergarten to 5th grade in the webinar handout. Now, if you didn't get that link at the beginning, I'll give it to you at the end. But let me show you examples of what they look like, right? I've made these matrices. I've got this one, which is for all of elementary, from kindergarten on the really early elementary on the front and upper elementary on the back. I also have grade level specific ones just for 3rd, 4th, and 5th grade. And if you happen to somehow be a secondary math teacher, I've got secondary versions of this, and I've got ones that go from 6th, 7th, 8th, also algebra, geometry, and algebra 2. So what's cool is if you look at this left column here on this page, right, the subtracted 3-digit number one, you can see we did those 3 problems together. But if you wanted to see what it would look like for other subjects, or not other subjects, but other concepts in mathematics, you can pick something that works for you anytime you want. So what I want you to now start thinking about, like I'm hoping you're really pumped about the potential that open middle problems have for your students. But maybe you're skeptical about like how your students will react to them. Like, will they like them? Will they be overwhelmed? Will they just give up? It's a fair question to wonder. So I want to share a few social media posts with you to give you perspective from teachers who are currently using Open Middle in their classrooms. Here's one from Chrissy Day. She wrote, I love Open Middle. Second graders were working on blank blank minus blank blank to make the smallest difference possible using the digits 1 through 9 only once. The conversation and perseverance was something I had never seen from these kids. Delana Ellis was saying it was an Open Middle showdown in 5th grade. They could not stop. One student even asked me for his paper during recess so he could try to get even closer. Like, that's a great opportunity. That's when it feels great to be a teacher. And this is one of my favorite ones. My students live for these. Nearly every day I'm asked, you got any more of those open problem things for us to solve? So, I really think that these problems, it's like the magic pill, right? They bring out misconceptions. They lead to these really powerful realizations. Kids love them. So let's wrap up this section and talk about why I believe we should be using fewer worksheets and more open middle problems. First, let's kind of review the critiques I made about worksheets to highlight open middle problem strengths. First, remember that you still get the same repetitive practice and time to think on your own when you're doing open middle problem, except now they don't feel anything like busy work and kids love doing them. They help build conceptual understanding. They lead to great conversations as you hear kids arguing about who got the best answer, and they give us much more clarity about which kids understand what and and what we're teaching, like which kids understand what we're teaching them and which ones really have hidden misconceptions. So that's what I think we should be doing instead. We should be doing more open middle problems with our students. So now let's talk about how we do it in our classrooms, right? Because like one concern you might have about using open middle problems is that kids will not want to persevere and they're going to want to give up. And guess what? That is totally going to happen. The reality is that most kids are not used to having to persevere like this, and it could make them think that they're bad at math or for not getting the right answer on their first try. Fortunately, I've created a tool that will make handling this so much easier. I call it the Open Middle Worksheet. So I've got 6 versions of this, 2 for English, 2 for Spanish, and 2 for French. Let me show you what the 2 versions look like. First, there's this student worksheet version, the student handout version, right? Where it's got the first attempt, the second attempt, and the third attempt on the front. On the back, it's got the 4th, 5th, and 6th attempt. Now, let me explain why this is so valuable. I think that we have the incentives in mathematics all screwed up. Like, the incentives right now are how do we get the answer as quickly as possible using the least amount of effort, right? Because if you can't figure it out quickly, then you should give up. Consider, say, on the opposite of that, English, right? No one expects you to get like a paper or an essay or a letter done on your first draft, right? We expect that there's going to be revisions and more drafts and eventually a final draft. But in math, it's like immediately we expect there to be a final draft. So this worksheet makes people realize like there's going to be multiple attempts. And you'll notice that there are points that are awarded, right? Up to 2 points for each attempt, after 2 points for each explanation. So I'll tell kids like, I really hope you don't get it right on your first try because you're going to get at most 4 points. I hope you have multiple attempts. And this has worked really well for me every time except once. I was teaching my son's 2nd grade class, and I was not paying attention enough to one group who was trying to figure out all the ways to get it wrong so he could get maximum points. So don't let that happen. But the reality is that it flips the scripts, right? It helps kids realize that even if they get it wrong, that's actually not a bad thing. That means they're getting more points. So that's great. I also have what I call a document camera version where it has each attempt on one sheet because this one doesn't really project well. It's too small of a font, but this one works great if you want to project it on a screen. Excuse me. So when students want to give up with these rigorous open middle problems, we can use an open middle worksheet so they want to keep trying and develop a growth mindset about mathematics. Next, you might be wondering, like, where do we fit this in, right? Like, you've already got a ton on your plate. I don't mean to make you have more. So where does this fit in? What I want you to think about is that open middle problems are great for places like classwork and homework, right? If you were going to have kids do a worksheet or maybe a textbook sheet, like page 47, problems 1 through 20, whether it's classwork or homework, anytime you're going to have kids do that repetitive practice is a good time for open middle. Like, if kids, let me be honest, I used to give kids problems 1 through 60 odd for classwork and 1 for 60 even for homework. And I did that because that's what I thought teachers were supposed to do. Like, that's what teachers did for me when I was a student. But what I realize now is, like, what benefit did they get from all those extra problems? Like, if they could do the first 3 or 4 problems, like, what more were they getting for the another 20 of them, right? Instead, now I'm at a point where if they can do, like, some really basic problems, why don't we just give them an open middle problem? Like, one open middle problem could be the entire classwork, could be the entire homework. Like, you're gonna have a lot less parents complaining about homework when it's one problem. Also, think about the potential for putting open middle problems on assessments. Like, what we have to realize is that if our quizzes and our tests are filled with problems like problem 1, but nothing like problem 2 or 3, then there's a really scary chance that our assessments are giving us a false positive result about what our kids know. Like, for example, if the scores that kids are getting, like the grades that they're getting in your class and the scores they're earning on your tests are higher than the scores they're earning on their standardized assessments, maybe we're not asking the right kinds of questions, and maybe open middle problems can help us identify those gaps and close them. So that's how we do it in our classrooms. Let's talk about where we can get more of these problems. The website is called openmiddle.com. It's called Open Middle. You can go to openmiddle.com to see it. Let me kind of tell you all about it. You'll see in the top left, we have, going from left to right, we've got this black menu bar, and you can search. You can kind of pick what you want there. If you're not sure where to begin, you'll see in the center of the page, it says challenging math problems we're solving. Download our favorite problems from every grade level. So you can click on that blue Get Our Favorite Problems button, and it'll share with you the single favorite problem that our team has selected for each grade level, from kindergarten all the way through calculus. You'll see kind of over on this top right side, there's a search bar. A lot of people love to search for their topic they're searching for. You can get a sticker for Open Middle. You can download the worksheets that we're talking about, that Open Middle worksheet. And you can kind of download number tiles. Like, if your kiddos are struggling because they keep repeating digits, you can download printable versions of these number tiles, 0 to 9 or -9 to 9. I also have elementary and secondary versions of a webinar very similar to this one here. This is what the basic problem page looks like. This one's a secondary problem, but the basic idea is the same. You got the title right here. You got the directions right here. If there's an image, you got it right here. Now, I highly recommend you copy and paste this into something and then print it from there. This is not a website you want to send your children to because they could click right here. And if you click on this, you will get a least helpful hint. It's a hint that will kind of tell kids enough to nudge them in the right direction, but not give them the answer. If you click right here, you'll get an answer. Again, it's not something you want kids to have easy access to. But we have something like in the neighborhood of 200 problems for elementary currently. I will say it's a little bit of a bell curve, so there are fewer problems at kindergarten and calculus, and there's a lot of problems around the 3rd, 4th, 5th, middle school, early high school. So you can find what you need there. So that's where we can get more problems. And I want to talk now about what comes next. So I hope you're excited to try to use these problems with your students when you go back to school. But what I want to give you is a way to process your next steps. I've made this table for you. On the left are potential actions you can take, right? Then you have 3 options. Do this action now, start planning this action, or don't do it. So here are your actions. Try Open Middle problems out with your students. Find more problems I can use on the Open Middle website. Incorporate Open Middle problems on your assessments. Replace all traditional problems with Open Middle problems. And share these resources with colleagues to make them aware. So I'm going to give you 30 seconds now to think about what your answer would be to each of these. So I'm going to explain my answers now. What's important to realize is these are just my answers. These are not like the correct answers. If you're if you and your colleagues are really familiar with open middle, you're probably going to have different answers than a person whose school, they've never heard of open middle. This is the first time. So take it with a grain of salt, but here's how I process these. I think that you should immediately try using these problems out with your students. I would say that I recommend using like easier problems, even if that means that they're from a lower grade level than what you teach. But try them with your kids and just see what happens, right? You may find that it works really well, or you might find that there are areas you need to focus a little bit more on. Next, I would also say, go find problems that you can use on the Open Middle website. Like you can make your own, but I highly recommend being lazy and go find the problems that are already made, right? A lot of them are battle tested. They have hints and answers, and it's a lot less work. I mean, you've got enough on your plate. So use the ones that are already there. In terms of incorporating them on assessments, I would start planning that. I wouldn't do it immediately. Like if your kids have never done an open middle problem and then you put it on the assessment, the results are going to be pretty much what you expect. It's not going to be great. I actually tried that the first time I did it. The first time I had made what would become an open middle problem, we put on an assessment, and 12% of kids got it right. Not my best moment. I learned probably better to use them with students before you put them on the assessments. In terms of replacing all traditional problems with open middle problems, don't do that. Like, it's not my intention to say open middle problems are the only good kind of problem. What I am saying, though, is that rather than give 30 of them, maybe give like 3 or 4, and once they can do it, like move on to something more challenging. In terms of sharing these resources, you know what they say, right? You have to hear things multiple times before you're ready. So I would start sharing maybe the webinar, maybe the DOK matrices with your colleagues, and get them really starting to think about the potential that these could have with their students. So I hope that you can see why I believe open middle problems are the single biggest buck for change any math teacher can make in her classroom. But if you're looking for more support implementing open middle problems in your class, I did want to share one more option to consider. Now, I wrote a book. It actually just came out in October of 2019 called Open Middle Math Problems That Unlock Student Thinking. Now, I realize it's grades 6 through 12, and many of you are probably elementary teachers. But what's important to realize is that the examples in the book, you can easily swap out and use the examples like in that matrix I gave you that was for elementary. If I was going to write a new version of this that was grades kindergarten through 5th grade, it'd basically be the exact same book. I would just change the examples. So if you've got different examples, and especially if you feel comfortable solving middle school math problems, you'll be fine with this book because the strategies are the same K-12. I wrote the book really to walk teachers through the entire process of using these problems, including how to choose a problem, how to prepare for a lesson, how to facilitate classroom conversations, what to do when things don't go as expected, and really even how to make your own open middle problems. I wrote a conversation like 2 colleagues chatting in the staff lounge. And I wrote the shortest possible book I could write. Like I figured very few teachers are thinking, I wish this book was longer. So, and I'll say that it's written for people who are both familiar and unfamiliar with open middle. So that's about it. Here are the resources that you can get if you want for the webinar. I've got a PDF copy of the presentation. I've got a link to a secondary version of this webinar if you want to share it with some colleagues. I've got links to all those DOK matrices, including the ones for elementary, secondary, and really 3rd grade through Algebra 2. And here's that link. So it's robertkaplensky.com/VMS20. So if you've already done it, you probably have access to it. But if not, head over there, get all the things you need. And thank you so much for making time to watch this presentation. I hope you really enjoyed it. I hope it's kind of opened your mind to maybe why we should reconsider using these worksheets. And I hope you loved it. So connect with me on social media or on my website, and I'd love to hear what you think. Thank you so much.
All right, guys. So that was Robert Kablinski's thinking behind how to get rid of worksheets, and to really dived into deeper thinking. I hope you enjoyed it. I hope you were able to get at least one thing from it that you can take to your classroom and start using with your kiddos.